All right, so sorry about the video having a delayed start, guys, but front page would have been with 12. Now, I'm okay with doing this a couple ways. I can either just show you the answers here if you want to check. If there's a particular problem, like an area of a rectangle 1, we'll probably just work that one completely together. But number 2, do we need to work number 2 together, or are we just going to check the answer? All right, so check it. When we write the vertex form with an a, an h, and a k, it's just this. A times x minus h squared plus k. This is all that I was after. This is what it looks like. Now, I gave you an equation already in vertex form. That's pretty handy. We have h is 2 because it's minus 2. There's our 2 and our k. That means our vertex automatically identified at 2, -1. The axis is symmetry, and I always ask both of these because we want the connection between it runs through the vertex. X equals 2. Every time, always the same coordinate. Okay, to graph these, I had somebody say, do I need to use 3 or 5 points? And I said yes, because there's no real clear answer. All you see me doing, how did I choose 2 to begin with? Yeah, it's the vertex. I always want to start here. Now, I did a little bit less work on mine. I just did a little bit of mental math. If I did 2 minus 2, because I plug it in 2, it gives me a 0, right? Here's my 0. 3 times 0 is 0, minus 1 is -1. Cool. I then will choose 1 away. Now, it doesn't really matter if we chose 3 or 1. We're going to get the same number. I elected to use 1. If I plug in a 1 here, 1 minus 2 gives me a -1. And you guys might have chosen 3 to avoid that. If you don't get goofed up and you take -1 squared, it's 1. So we had 3 times 1 is 3, minus 1 is 2. And then I get 1 more, it's 0. I didn't do any of the work to get there. It's 3 times -2 squared, which is 4. So 3 times 4 is 12, minus 1 is 11. If you used 3 and 4, you should also get 2 and 11. Same way. Now, all I've done on the graph here is we just go ahead and plot those 3 points. Here's 2, -1, 1, 2, and 0, 11. And I just reflect these over that axis of symmetry that I didn't draw, but we could, right through here. Awesome. Okay, this would have been and will be worth quite a few points on your exam. Okay, feeling okay so far? Okay, on number 3, real quick, I want you guys to check, do you guys have solutions? You do not need solutions. Okay, and I just want to, so we don't even need the roots. Roots are solutions. I don't need an x equals anything here. Let's read through it really carefully to see why that might be the case. If you've solved them, cool. You're doing more work than you need to, and you're getting practice, which is good. First off, if I give you the quadratic in this form, ax squared plus bx plus c, the discriminant is just a part of the quadratic formula under the square root. It is just that b squared minus 4ac. Okay, that is it. Now, on b, if you solved it, I'm going to point something out here real quick. Use this, whatever we just found, to determine the types of solutions that you will find for each of the following. In big capital letters, it tells you do not solve. You can. It's not going to hurt you. You do not have to. All I need to know is how many roots are we expecting and what type are they. Now, if you don't recall, if I take a square root of something, there's only 3, there's a lot of possibilities, right? Because infinitely many numbers. But I'm going to claim that we could make it 3 distinct categories. I either take the square root of a positive number, which means there's 2 roots to it. For example, the square root of a positive 9. 2 numbers. What are they? 3 and -3. There's 2 numbers, right? Okay, it could be positive. Doesn't matter if it's a nice 9 or 11, whatever, it's just uglier. What about 0? How many square roots are there if the number is 0? What's the square root of 0? Do you have to tell me positive 0 and -0? No, it's just 0, right? And we just found 1 root just now, and it was a real number. The only other possibility is a negative. The second we start trying to take square roots and negatives, who shows up? I do. Yeah, okay, all right. Yep, indeed. So check it out. Here we are. For these, all you really had to do was just the discriminant. So here it is. Notice I'm not trying to solve it. I find the discriminant is 25 plus 28. Now, I know that's, what, 53? Don't really care that it's 53. I care that it's positive. As soon as I know it's positive, I know that there are 2 real roots. That's all this problem was asking. Now, if you found them, cool. Negative 5 plus or minus root 53 all over 2. Cool. You can find them. You don't have to. Okay. On this one, when we find the discriminant, it's b squared minus 4ac. I realize it's going to be 100 minus 400, which tells me I'm going to be taking the square root of a negative number. There are 2 imaginary or non-real roots. Cool. The last one. The discriminant winds up being 75. I don't really care what the square root of 75 is. All I care is that it's a positive number and tells me there are 2 real roots. Cool. Sebastian. It would be no real roots. If you wrote no roots, just say no real roots. Because it does cross an axis, it's just not the x-axis in the part that we get to see. Because remember, there's a whole portion of it that's invisible, which is why I like that number invisible more. Okay, for this page, if you're keeping score for yourself, let's see, there was 1 point here, 2 points here, 4 points here. Did you try to table? Did you make the points? Did you try to graph it, and does it match your table? And then on this bad boy, there were 10 points. There's 1 for tell me what the discriminant is, and then for each of these, did you use the discriminant? Did you find the value? And whether you actually gave me the value or not, did you get enough to see positive, negative, or 0? And did you tell me how many roots there were? Cool. All right. We are going to do the word problem here together. Now, as we go through this, word problems, it's always kind of like a double-edged thing. And the reason that I'm saying that is when we do word problems, I want to make the math as realistic and awesome as possible, right? Okay, here's, it's going to sound dismissive, but it's not the intent. Are we in a super high-level math course right now? We're like middle of the road, right? Like, we're pretty far up there, but there's a couple classes even at this school beyond this class. When we get more and more sophisticated in just the math that we do, the word problems get better and better. Like, we can do a lot of physics in here with quadratic stuff, and we have done quite a bit of physics, the height of an object at whatever. But to be honest, all of that done with algebra is kind of bleh in reality. There's a whole field of math that was created for the use of doing physics. It's called calculus. We can see all these same ideas, but we get much more meaningful word problems as we get into bigger stuff. Like, we'll start throwing more. There's some places that we can use them here, but they're not the best. So here's this. We have a rectangular frame, and we know that the length is 7 inches longer than the width. We're also told the total area. So we need to define our variables below. Now, for this, what I was seeing as I came around, and a lot of you guys have it, W and L, right? Like, that makes sense. Now, here's the issue, though. If we have 2 unknown things, and we multiply them and get 18, can we solve for both of them? Can you have 2 unknowns in a single equation and solve both? You can solve for one or the other in terms of the other. But let's look at this. We have something equals width, right? That's what it was written on it. I guess I can just look. What do you want to call the width? I'm cool with X. There's a more natural choice that somebody might take W. I'm going to call it X because it looks common. Okay. Here is the weird part. We're not going to use a different one. I know that the width is X inches, however long that is. And the length is what? How much longer? 7 more. What's 7 more than this then? X plus 7 is the length. Now, once we have this and we have it in a single variable, we just define the variables. If you use W and L, I think I would probably give you credit, but you're not going to be able to solve the rest of the problem with W and L. Okay, we now want to use these expressions for width and length to find the dimensions of this frame. Okay, so we need a way to do that. Well, do we know the area? It's 18 square inches. And how do you find area of a rectangle? So you could do length times width, and I could write L times W, or base times height, whatever variation you want to use. Do we know what width is? What's width? And what's the length? And when we multiply width times length, what are we going to get? 18. Now, we need to solve this equation. And there's a few different routes that we can go. We will ultimately do what first to be able to make sense of this? We're going to distribute immediately. Okay, once I get here, x squared plus 7x equals 18. We are at a point where we need to make a decision. We can solve this either by factoring, which is what I would suggest we do, and I think is going to be easier. But we could also complete the square to solve it. Would you rather complete the square, or would you rather just factor it? So how do we complete the square would be, I take 7, I divide it by 2, and I get 7 halves, and then I square it, and then I add that to both sides of the equation. I would rather factor it. If you completed the square, Michael, you're fine. It's not the way that I would go. And let's just see whose work requires more effort. Okay, so if we commit to factoring, which I'm going to do right now, and just so you guys can tell, one thing that tells me I'm going to commit to factoring is this is already a 1, which means I'm thinking shortcut already if I try this. Okay, if we are trying to solve this by factoring, what do I set it equal to? Okay, what should I immediately do then? Let's subtract 18 from each side. Okay, by doing this, as long as we don't forget our equals 0 so that we don't forget to solve it in the end, the rest of this problem should be super smooth sailing. There's no GCF. The leading coefficient's 1. What do you get if you multiply these A and C? Negative 18. And now we need two numbers whose product is negative 18, but they have to add up to what? To 7. So 9 and 2, one of these better be negative. 2, because 9 plus negative 2 to get our positive 7. Okay, do I have to do the grouping stuff? How does my shortcut work once I found these numbers? X plus 9. I just use the positive. It's positive here. And x, and what's the other number? Minus 2 or negative 2. And it's still all equal to what? 0. Now, for this one, you might show your own, you might not show any work here. But remember, I'm claiming this times this is 0. Means either this is 0 or this is 0, right? Let's see, what shakes out. If my first factor, x plus 9 is equal to 0, what do we get for x? Okay, I'm going to claim that this is absolute garbage. Why is this not going to work? Yeah, show me a frame whose length is negative 9. Not going to happen. Okay, get out of here. The other one, x minus 2 equals 0. If we set that factor, we get x is equal to what? 2. Is that a reasonable value? Yeah. Now, do we say what the frame is? Is it a photo frame? Nope, just a frame of some sort. I don't know what they're hanging up, which is fine. Are we done? Not quite. What is problem B actually asking us to find? We want the dimensions. So here we go. We'll write it out. And I'm going to make this as the dimensions. I'm going to put it in my context. The frame has dimensions. And I notice that I still have this up on the board, which is awesome. X is what? 2 inches by, what's 2 plus 7? 9 inches. Boom. Does that give me an area of 18 square inches? Yeah, 2 times 9, we have it. Okay, this problem, if you can connect that x and x plus 7 rather than 2 variables, hopefully this doesn't feel terrible. Now, there's a little bit of a word problem in here. Certainly you guys feel it, and it feels like more of a word problem than anything else. But once we get this identified, is it really any different than everything else that we do? No, I hope not. Okay. Do we need to do number 5 together? Okay, let's take a look. Now, when it has words in it, it's uglier, right? So let's just try to make sense of this, and I'm going to put the actual stuff up on the board here. I'll cover up all my work. But let's look at the problem and see if we can't make sense of it so that we can make it feel like just a regular old math problem rather than a big, ugly word problem. Okay, we launch an object from some tower. Awesome. The height in feet at some time is given by this equation. Now, I notice right away that this is a quadratic. Do you guys agree with that? How can I tell it's a quadratic? T squared, right? Now, they use t instead of x. That's okay. Okay, they want us to find the time it will take for the object to strike the ground. Now, it feels ugly and it's wordy for sure, but let's just think about it for a second. What does h of t represent? The height, and we're trying to figure out when it hits the ground. What's the ground's height? Okay, if I just take this whole equation and I set it equal to 0, am I finding that I'm going to solve the time where height is 0, right? So let's take the math out of it. I'm going to write that then over here. We need to know if it strikes the ground, the height is 0. So let's write that. 0 is equal to, and I'm just going to write our equation, negative 16t squared plus 64t plus 16. That first little piece of being able to take this really wordy problem, does it feel different now if we take everything else out of it? Like, does it feel like a word problem anymore up on the board? No. If we want to solve this, could we use a quadratic formula? Yeah, don't. I even suggest you could if you needed to. I don't know if we need to. Let's see, because that's always our last stop. What's the very first thing I should always try? Is there something that goes into 16, 64, and 16? What is it? 16 goes into all three of these. Now, I'm going to suggest I don't want to take out a 16, though. I'm going to take out a negative 16. Liam, why would I take out a negative 16 instead of a positive? Check it out. This quadratic that is now in here, t squared, is a positive 1. That's a leading coefficient of 1. That's a super handy thing to have. Minus 4t minus 1, right? Cool. All right. So here we are. No, what? Now can we use quadratic formula? Should we just commit to it already? So we will here in a second. We're not going to commit to it yet. What should we check about this first? Okay, so I know the square root of t squared. I don't know the square root of negative 1. Now I do, but we can't use it. Gosh, can you find factors in negative 1 that add up to negative 4? Okay, so now we'll go ahead and commit to it. If we want this negative 16 to disappear, we're allowed to. One more time. You could complete the square. But again, the quadratic formula is like we've completed the square, the most general form. Absolutely, you're going to get the exact same answer. Okay, if we can't find these numbers, I would just jump to the quadratic formula. So t is equal to, what's negative b for this one? 4, because negative opposite, plus or minus the square root of, what's 4 squared? 16 minus 4 times a times c, all over 2a, which is just 2. Okay, we're going to clean it up a little bit. This is 4 plus or minus, what does my discriminant wind up being? 20. And I'm going to break down 20 right now. Instead of writing 20, is there a better way with square roots that I could write it? 4 times 5. Now, it's still 20, and I'm just going to make a note. 20 equals 4 times 5, just so we can see where that happened. Why would I rewrite it like that? Yeah, 4 is a square number. We can clean this up. So here we go. 4 plus or minus, what comes out of the square root? Okay, so I'll take the square root of 4. What stayed inside the square root? 5 and all over 2, right? Okay, maybe both of these numbers work. I don't have a calculator handy, but I want you guys, if you have a calculator available, tell me, what do we get? And if you don't have a calculator available, I would encourage, if you think that you might not be able to type this in without making a mistake, you should go grab one and verify that you can do it. 0.26 approximately, and what's the other one? Is it not 4.26? Oh, 4.24? Okay. 236. Okay, so 4.24 or negative 0.24. One of these doesn't make sense for the amount of time it'll take for it to hit the ground. Yeah, that doesn't make sense in this problem. So we've now solved it. Have we actually answered the question? No, we need a lazy sentence, and doesn't have to be like groundbreakingly beautiful or anything like that. What happens at 4.24 seconds? The object, whatever it is, I don't know what it was other than an object, hits the ground after 4.24 seconds. Indeed. All right. As we're looking at this, if nobody in here has ever done it, but we all are very aware that like planes and drones fly around and drop bombs around the world. Guaranteed this math goes in, like there's a little bit more because of air resistance and stuff. But if you want to know if I'm flying this fast and I drop something, how long is it going to take to hit the ground? Like when they dropped the nuclear weapons in Japan, like they had to know how long it's going to take for it to hit the ground. How far are we going to be at this time? Like they weren't sure if they were going to live when the bomb exploded. But they were pretty confident because they trust the mathematics. Cool. All right. Deal. Number 6, I think, is like the hardest problem on the whole test, in my opinion. I think number 6 is the most challenging thing that we do, completing the square. Like, okay, we'll check real quickly. Number 6, if I give you a function in not vertex form, changing it, do we work this one together? You just want to check the answer. All right, so check it out. If you already have it, I'm just going to show the answer real quick. Don't just blindly write it down if you don't. If you already have it, I would encourage, if you don't need to work through this, if you want to quietly start working on your note card and not follow along with the problem because you know how to do this, doesn't hurt my feelings as long as you're not distracting everybody who needs the help with this. Okay, so let's do this. 2x squared plus 4x minus 1. F of x. 2x squared plus 2x minus 1. Okay. We are going to write this in vertex form. Now, to write something in vertex form, we need to be able to complete the square. Now, this is one of those weird situations. We aren't going to mess with both sides. Yes, sir. Thank you for that. That saved it. It would have made it a much uglier problem. So for those of you grabbing a note card, remember, I want you to work along with this if you weren't able to do this on your own. Cool. Didn't I give you guys note cards last week? No? Okay. I'll pass out note cards here in a minute. If whoever's standing, you can grab one if you're already up. But I'll pass them out. Okay. To complete the square, this problem, we need to make sure we can differentiate between them. Are we going to mess with the left side of this at all? No. I want to keep this as f of x equals or y equals something. I don't want to touch the left side of this equation even a little bit, which means whenever we add something, it's that clever choice of 0, which is that weirdest idea. The first thing that I notice, we do not want a 2 right here. Don't want it to be a 2. What do I want it to be? So we're going to factor a 2 out of which terms? Factor a 2 out of, and I'm just going to say terms with x. Okay. When we're doing this, it's a 2 in this problem because it's a 2 here. That's the only thing. So when we do this, let's knock it out. 2, what stays inside my parentheses? X squared plus 2x, I'll close it, and minus 1. Okay, now, in my work, I wouldn't really close this. I would continue on. But right now, if all we've done is rewritten it, if we distribute it out, we get the exact same thing. Okay, now, here's the weirdest part. We need to add a clever choice of what number that doesn't change stuff. We needs to be a 0 in the end, right? Now, that's a wonky thing when we say it, but it's not like we're just going to write plus 0. We're going to add something and subtract something. How do we figure out what we're going to add and subtract? Louder. So b over 2. So this is a, b, and there's no c in here. So we're going to take b, this one, and we'll take that and divide it by 2, and then we do what to it? Square. Cool. We're going to add and subtract whatever this is inside the parentheses. I've lost my spelling. Parentheticals is another parentheses. Like, it's the same thing. Yep, it's a real word. Okay, so here we go. I'm going to add, what's 2 over 2? And square it. So I'm going to add a 1 inside of these parentheses. So we'll leave some space so I can add the annotation. 2x squared plus 2x. A big awkward empty spot in there. And here's my plus 1 minus 1. Now, it's ugly, but what did we really just add? 0, right? Like I haven't changed it. It just looks different. Now, this is always the weirdest part. I could claim simultaneously that instead of adding 1 and subtracting 1, I could say I really truly added 2 and subtracted 2 because there's a 2 stuck with distribution. Okay, one of these doesn't belong in here. Which one don't I want? The negative, because if we forget about the negative, then the square root of this is x, the square root of this is 1, and this is now a perfect square trinomial. How do I get this negative out, though? It's stuck by multiplication. Let's distribute this to be able to get it out. So we'll distribute, and this is going to be very specific to this problem, right? So we'll just say from here to here, distribute 2 to the negative term. I'm going to say to the negative 1 to remove. Okay, so here it is. And little steps through this one will help us avoid mistakes. If you are comfortable with this, you might take much larger steps and have way less work, and I'm cool with that. Okay, when I distributed that negative, or this 2 to the negative 1, what came out? Negative 2 there. And then there's still what number outside still? Minus 1. Now, we're going to do 2 things in this last step, and then I'll show you the amount of work that it takes on mine, because this is much more detailed, but much more helpful, I also assume. Okay, we're going to do 2 things. We're going to factor the perfect square trinomial that we now have in front of us, and we're going to combine any like terms out here. So let's do that. What's the square root of this term? Square root of this? And what's the sign in between them? Check it out. There's our perfect square factorization, x plus 1 squared. And then out here, negative 2 and minus 1? Negative 3. And we now have a wonderful quadratic written in vertex form. Every time the same process is going to get followed if we're trying to find the quadratic or the vertex form of a quadratic equation. Okay, 100% I guarantee there will be a problem like this on the test tomorrow. Like, just so you're aware, it is there. What I will do is I'll make it so that it's not an ugly fraction. Like this one worked out nicely. 2 over 2 was convenient. If it had been a 3 inside here, this problem gets a little bit uglier. It's the exact same process, but it's a fraction game at that point. I will not give you a fraction one tomorrow. Cool. All right. Do you want to see the amount of work that I do these with? This is what my problem looks like. Like, I think that if you guys notice that there's a 2 that comes out, you could rewrite it. I then just leave this awkward space here for just a moment, and then I say, well, let's do the b over 2 thing. Here's my adding 1 on that next step. I then can distribute and factor it in one line. Now, it might take you more than one line of work, and I'm totally cool with that. If you're confident with it, and when asked, you can explain to me how you did this in one line, I have no issue if you can do it in one line of work. That's fine. If you need to do it in 4 or 5 lines of work, equally fine. Exact same thing happening, just breaking down my steps little by little here. Is that the hardest one on the test? Is that the hardest thing we've done this chapter? What do you guys think was harder than that? Okay, that one didn't show up on here, did it? Okay. Oh, yeah, it did. It showed up right here. So it did once. Check it out. Here's 2 equations, f and g. Now, I've worded this a little bit differently, but it's the exact same thing. Where do these guys cross is just saying solve the system of equations. So what I recognized was f of x is just a placeholder for what other value could we possibly put here? Now, you could put 0 if we wanted the 0, but we could use f of x or y, right? This is y equals this, and this is y equals this. We just have them named by rules. If they're both the same thing, where we want to know when are they equal, because that's what it means to intersect, we set them equal to each other. I subtract 4 and 2x from both sides, and I realize that I have a wonderful difference of 2 squares. I did not write the factorization here. How does this one factor? X plus 1 and x minus 1. And I always do the minus first, just the order doesn't matter. But here are the x's that I come up with. Now notice, I didn't just write plus or minus 1. I wrote both of them. Bless you, thrice. I wrote both of them so that we could keep them consistent in order. If I got a 1 for x, I could plug it into this or this. I would do this because it's easier. What's 2 times 1? Plus 4? Hey, look at that. 1 and 6 is one of these ordered pairs. If I do the same thing with -1, I'm going to get -2 plus 4 is a positive 2. And here's my other intersection. I also saw somebody had a big stack of them. I don't know where they took it, though. Okay. One hiccup on the 8 through, or on number 8. E is a typo. If you didn't realize it, my guess is you probably found -5 and 4. I saw somebody did it, and I started to do it as well. You can't really tell, but I started erasing. Because I need factors of positive 20 that add up to -1, right? Can't do it. Where do you think the typo should have changed? The negative. If you haven't done this problem yet, change it to a plus 10. That is my bad. As soon as it is a plus 10, it works out super nicely. Somebody who had it done before, do you recognize where it doesn't work? Okay, so then if you did it the other way, then that's awesome. Then you probably got the right answer. But check it out. We'll come back to this one. GCF, that's all there is to this one. You take it out. We use a zero product property. If we set our first factor equal to 0, it's just x is 0. If we set our second factor equal to 0, you would have to subtract 1 and divide by 2. I'm sorry, let me focus here. We have two solutions, 0 and -1/2. If you take this one right here, Kennedy, and solve it, forget about the x here, do you agree we'd subtract 1 first? And then we'd have 2x equals -1. Divide it by 2 to get x, and we would get -1/2. Okay. All right. On B, I told you to use the difference of squares. Can you use it immediately? Not quite. But the good news is that before you do a difference of squares, you're always going to check for something else first. What goes into 3 and 27? Hey, here's a 3 factored out. It leaves us with this wonderful difference of 2 squares, which factors as x minus 3 and x plus 3. There's never a value that's going to make this 3 equal to 0 because 3 is always equal to 3. There's no x in that very first factor. Okay, so nothing there. What makes this factor equal to 0, x minus 3? What makes x minus 3 equal to 0? 3. There it is. What makes x plus 3 equal to 0? And there are our two solutions. Difference of squares and done. Okay, on C, it is just a lovely quadratic formula. -5 plus or minus the square root of 21 all over 2. Yep, notice I didn't approximate it. Don't need to. If all I'm asked to do is find the zeros, I have no interest in grabbing my calculator to get an approximation here. Cool. All right, on delta, shortcut. Factors of, we have to add 7 first, but we add 7, and now we're looking for factors of 7 that add up to -8. What could those be? -7 and -1, and there they are. We set those equal, each factor equal to 0 as they're multiplied, and we get 7 and 1. Okay, let's look at this one together with the appropriate number. I'm running through. There's no GCF. That's a bummer. There is not a leading coefficient of 1. Bummer. I'm not going to commit to the quadratic formula yet. I'm now going to multiply. What's -2 times 10? -20. And now we need factors of -20 that add up to what number? -1. What are those numbers? I think you're backwards still. I think you just said the same thing. Okay. We cannot just jump right to our shortcut, right? There's no shortcut here. If we want to factor with grouping, we rewrite this trinomial or trinomial with 4 terms. We're going to replace minus x with these two. And let's just see what shakes out. -2x squared minus 5x plus 4x plus 10. And it's still equal to what? 0. Now, by doing this, we give ourselves an even number of terms, which can then be split into 2 different groups. Anything that comes out of here? X? You want to do -x? I'm good with that. What does it leave behind? 2x plus 5. What could we possibly take out of this group to ensure that I leave behind a 2x? A 2. If I take a 2 out of that, it's a 2x plus 5. I can now see both factors. What is one of them? So I heard both of them, but one of them is negative x plus 2, those numbers in front. And the other one are these that are matched up on the inside. Remember, this is just a fancy rewriting a FOIL. My other factor is then 2x plus 5 equals 0. And I'm going to just do a little mental math. If I had negative x plus 2 equal to 0, could I add x to each side? I'd have x equals 2, right? Okay, so x equals 2. This one is a little bit uglier. If I wanted to solve this, 2x plus 5 equals 0. We would subtract a 5, and then we divide by 2. So accept the negative part. I like it. And there we are. Cool. All right. Last one. There is never, literally never a time that I would probably complete the square. It is faster than quadratic formulas sometimes, but if we want to complete the square, a couple ways that we can do it. What I realized is that I wanted, if I take this and divide it by 2, I get 2 squared is 4, right? Now I could move the 7 over initially. That would have been fine as long as we add 7 to both sides of the equal sign. But what I did instead was I noticed that, hey, if I just added a b over 2 squared here and here, then this is already a perfect square trinomial. And by doing that, here we are, x plus 2 squared on this side, it's perfect, equals negative 3, and then we're just going to run through it. I'll take the square root of both sides. I realize that a negative number has an I come out of it, and one step away, subtract 2, and we're done. Okay, tonight, what do you think you should do? Probably study. For this, I'll tell you, I don't anticipate to have a problem exactly like this one that says complete the square. I do want you guys to be able to factor using methods other than the quadratic formula, so I'd be prepared for that. Overall, your test, is it going to be as long as this was? Not a chance. Not a chance. To make it a little bit shorter, typically what I do is, instead of saying there's 12 different problems, I can say 3 of them all relate to this. Cool. All right. I will be here at lunch. I will be here for a bit after school. I'll see you cool cats and kittens tomorrow. If you would like a note card, they will be up here on Talia's desk. Yes, sir.
Wait, wouldn't that be negative 5? Because
if I add 4 to each side?
Why 4?
Because what's b over 2?
2.
Squared.
Oh.
Yep.
Okay.
Yep.